here's the funny thing. Not, like ha ha ha. They leave at the same time. And then you wait until they're a certain distance apart. Did either one travel for more time than the other one? So then both of those are going to be what?
X.
That's the one time you make the variable the same as if you know they're equal. And why are these both x? Because if they left at the same time and then you stop right when they're 3:25, they both were traveling for the same time. Yes? Maybe? No? There's some discussions happening about, does this guy make any damn sense? Some days he is. Or, I don't know. And then, of course, 70x, 60x. This is beautiful. Holy shit. And what are those supposed to do? Add to be 325. I like it. So 70x plus 60x. I mean, you can't beat that equation. What is it? 2.5? Ooh, it's not so bad. So 130x equals 325 divided x is 2.5. And this is beautiful. That's the only thing you got to worry about in this problem because they're both the same. So 2.5 hours, they'll be that far apart. Yeah. Yes. Okay. I like it. So again, this chart isn't by itself. It's new, but it's not like a. It just helps you organize things. Okay. So, last few things I want to talk. Can you bring the lights back up? Thank you. I want to get into some basics of graphing and then let us out. Unleash us on the world. Have you touched? So, we've already had some stuff about graphing show up with the functions when we started talking about input and output and what they were related to graphing. So, I think we all should know the basics. Can everybody, in fact, let me just pretend like we haven't really done that. So here's a number line. I can graph x values on it. So what we decided was if I also wanted to graph something with more parts to it, I would put another number line perpendicular to this one. It's amazing. So this is the x, and this is remarkably enough the y, because math people aren't that creative. It was great. The urban legend is that, anybody know what the official name of this is? Not the XY plane is one way to reference it.
Cartesian.
Dude. Cartesian plane. Yeah, Cartesian plane. So there's a guy named René Descartes. René of the Cartes. No, René Descartes. Urban legend. There are some urban legends in math that are not quite as interesting as other ones. But he was sick looking at a fly on a ceiling. And he's like, how would I describe where that fly is? I could do a series of lines and then, good way to go, René Descartes and his fly that visited him while he was sick. All that doesn't matter where shit. You see this on a globe. Latitude, longitude is another classic example of this type. The neat thing about that is it's on a curve, and hopefully everybody does know we live on a curved globe. Okay, there's some flat earthers out there. Holy shit. 2 centuries of enlightenment, and they say, screw that shit. So, if I wanted to plot the point, let's not start there, just 2, -3. What's the first value that represents? X. So that's going to represent left and right motion. And then the second one's representing up and down motion. So it's kind of like telling you, if you've ever been to Utah, holy shit, they have their neighborhoods playing out. Perfect. And then Virginia Beach had there was a road that intersected with itself. I'll never forget it. Anyway, so it's like telling somebody to go over 2 blocks and down 3 blocks. Right? So where's this house? Why do I start here? What's the name of this point?
Ground zero.
Origin. Ground zero. Today's a rough day. Bring that one up. For sure, I like it, ground zero. So everybody knows what
That
it
was-
is, right?
Wasn't intentional.
I know, no, Arnold, I didn't mean to make that sound like it was offensive or whatever, it's fine. It's just, you guys know what today is, right?
Yeah.
Some of you guys might not have even been alive, just keep that to yourself. Because I
Actually, ground zero
remember,
became popular when that happened. You know, everyone started saying ground zero, right?
yes, it was known before then, but now we take it to mean that. Anyway, so we won't talk too much about September 11th, I don't know if anybody was affected by it. We all were, but I mean more directly. So 2, you go over 2, down 3. So that's where that house would be. 2 blocks over, 3 blocks down. I like it. So that's why we call this the origin, is because that's where we start counting. So what point would this be?
-1.
Negative 1.
2.
2. The first one's always left and right, it's the x. The second one's always up and down, the y. So this is negative 1, 2. Now here, just to blow your mind a little bit. How many dimensions of a world that we know of, that we can see, that we live in?
2D.
Holy shit. If we live in 2D, we can only live So obviously, what can I do? I don't have to live on the board, do I? I can have one, right now. I'm sorry, I'm sorry. I didn't mean to make you feel weird. Right now, how many dimensions are up here? 2. X and Y. I got left, right, that's 1 dimension. Up, down, that's the second dimension. But what can I do then?
Z.
Come out or in. So like this point here, stay with me, this isn't that bad. We're not going to talk about 3D after what I'm doing right now, I promise you. But I just want to show you it's not that big of a step. So a point wouldn't just have 2 parts to it. It'd be the left, right, the up, down, and then the out or in. Right? So the Z axis, why do I call it the Z? Because we got X and Y. Yeah, so the Z axis would come out like this. What the fuck? So then, right? And so I'd have tick marks along it. Are you with me?
Yeah.
So if I had the point negative 1, 2, 3, it'd be negative 1, 2, 1, 2, 3. It'd be right there. Right? But we're gonna keep it flat. Okay? In your future, maybe somewhere down the road, you might start talking more about 3-dimensional stuff. And actually, next semester you'll do some. Yes, you will. Ha ha. All right. That's enough of that. I'm sorry. If you're curious at all about, well, how do you graph 3D? Want to graph? There's actually 3D graphing bit. Yes. They have little cubic things. But again, that's it. So let me ask you this. This is the last thing for today. How much time do I have? Perfect. So the points we graphed came just from me giving you points, right? If the points come from a relationship, then there should be a pattern to what the points look like. So that's one of the most fundamental reasons we graph equations, is because the visual I get from the graph tells me things about the equations I couldn't see from just seeing the equation. So the most fundamental type of functions would be linear functions. So what if I had something like this? I don't know. X plus y equals 5. It's amazing. How many answers does that have? Here's another reason why we graph things. What the shit does that mean, Jeff? Can somebody tell me one answer? What does it take to give me an answer? 4 and 1. So an answer has 2 parts, an input and an output, but we'll get into why it's an output. It's got an X piece and a Y piece. Give me another answer. 3 and 2. 2 and 3. 1 and 4. 2.5. 2.5.
What about 0 and 5?
0, 5. Negative 1, 6. All right. You can keep going, can't you? How long could you keep going? Infinite amount of time. Because what about negative 1.972463342? There is a number there that would make it come out to be 5, right? Every freaking number. So the most fundamental reason why we graph equations is to answer the damn question, what are the answers? If I do it this way, I'm set. This is what I'm going to do for the rest of my life. And my kids, I pass it on them. You must finish this. And then they had to be, you almost finished. It's like, holy shit. Sorry, you guys follow what I'm saying? So if I just graph the damn thing, but now there should be a pattern, and it should be a very simple pattern because it's a very simple equation. When I start bringing squares and cubes and shit, that's when you start getting the nifty polynomials. But that's like, so how do I graph some of these points? Same way we just did, Jeff. Why do you sound so excited? So if I want to graph 4, 1, 4, 1, bam. 3, 2, bam. 1, 4, bam. Doesn't matter. Just need to graph a few of them. 0, 5, bam. -1, 6, bam. So even with my crappy scale, you can see they still line up. The minute I draw the line, I've included all the funky ass decimal possibilities. I'm passing through an infinite number of points. So somebody's like, that's not the answers I wanted. Well, then just keep going until you get to the one you want. I'm done. Next. I'm not going to bequeath this to my children. Continue this list. Yes?
How do you get these numbers?
We just made them up. All I wanted was to start making a list of answers. So what adds to be 5? 4 and 1. You with me? What are answers to this? 4 and 1 make 5. 3 and 2 make 5. All the way, all the way, all the way. I just wanted to do that to get two things. One, to see how that generates points. That's the answers to the equation are going to be points. And two, why I wouldn't do it this way to answer. I'd rather graph it. Woo! So we basically just stepped barely into section 4.1. No idea why that woo came, but I don't care.
We didn't finish it yet.
Finish what?
Chapter 3, we'll go to chapter 4.
I know, I'm insane. You probably want to get in there, do some homework, and ask some questions. It's amazing how it works. Oh, Jeff, you suck. So yeah, there's a couple things out of 3 we haven't talked about, but I want to freaking... It's up to you to go try them out and ask some questions.
So we don't have anything for chapter 4 yet.
It's just like barely into 4.1. That's what's in 4.1 is the basics.
Okay,
Yeah.
but that one comes in the test. That's one.